Good morning, guys. I'm sorry I can't make it today to class. I have a meeting this morning. So I wanted to make sure you were prepared for today's material. So I've got this hopefully about a 15-minute video giving you the gist of what is in this beginning part of section 5 in chapter 6. So today we're going to talk about imaginary numbers. The idea for today is to be able to convert imaginary numbers to the trig form, which will help us do a lot of things in the next couple of days with getting that from the a plus bi form to the trig form. In doing that, some of the things that we're going to talk about today are pretty easy and things that you have heard before. The first one being how to find the absolute value of an imaginary number. So when we look at imaginary numbers, for example, something like, grab this pen, 2 plus 3i. If we were asked to graph that, remember this would look like a vector. We would go and name our x-axis the real axis, and our yi would be the imaginary axis. And if we were to graph it, we would go over 2 in the real direction, up 3 in the yi direction. To find the absolute value, it's very simple. We're not going to memorize formulas. What we'd like to do is to be able to visually see what that actually means. The absolute value of an imaginary number, well, the absolute value of any number is the distance from the origin. So when you are looking here, if I were looking at the absolute value, this is the notation for the absolute value, I would be looking at the distance of this vector right here. Well, if I sketch it and I drop the altitude, I can use the Pythagorean theorem, which we know and love. So I'm going to go over 3, up 4. If I use the Pythagorean theorem, I would get that actual value, which is the distance of the imaginary number. So if we look down below, let's look at maybe 1. In order to find the absolute value, I would sketch it. So we're going to sketch the imaginary number. This is my x-axis, my real, my yi. If I go left 4 and up 2, this is where my vector will end up. If I drop my absolute value, or my altitude, that's 4 up 2, and now I'm back to just doing the Pythagorean theorem. So c squared equals 4 squared plus 2 squared. C squared, that's going to be 16 plus 4, which is 20. And when I solve, I get the square root of 20. Remember that when you take the square root and you're talking distance, that value is always going to be positive. And I don't need to simplify that radical. Pretty easy to do. Okay. I've given you the key to the notes so you can look at the other 3 examples. Let's take a look at the next page. So the idea is here to take your imaginary a plus bi form and convert it today to a trig form. That's the basic end goal of today's lesson. To do that, there's a few things. Number 1, I'm going to graph my imaginary number on my y-axis. And what I'd like to do is to get to this form, which is the trig form of your imaginary number. So we're looking for an r, which is going to be the actual distance, and then we're looking for an angle in order to make that conversion. Now, this form right here is sort of a fancy way of the form that we're going to look at, and I'll get back into that in a little bit. So, to find the r, I'm going to use the Pythagorean theorem once I sketch. And to find the angle, I'm going to use some of the trig ratios and things I've known in the past to get me that angle and location. So let's jump right into a problem. So step 1 to convert is to get myself my r value. So I'm going to sketch that imaginary number. I'm going to go my real, my y-axis, left 2, up 1 puts me in the second quadrant. I'm going to sketch that vector, drop my altitude. This distance is 2. This distance is 2 as well. So to find my r, that's going to be the Pythagorean theorem. So r squared equals 2 squared plus 2 squared. So r is equal to the square root of 8. I'm going to make it 2 radical 2. Just like to simplify that radical. You don't necessarily have to, but you might want to. Now, to find that angle, I'm going to use tangent. I have O and A. I'm going to find my reference angle, and then I will figure out this large angle. So the tangent of theta is going to be 2 over 2. Those are the pieces that I'm given, O and A. So the tangent of theta is equal to 1. We all know, because we've memorized, I don't know, 4 months ago, what angle has a tangent of 1. We all know that that's 45 degrees. In radians, it's pi over 4. Now, in the next 2 days, you're going to see me probably use a little bit more degrees than I will radians, only because sometimes it's a little bit easier. Again, it doesn't matter. You can give an answer in degrees or in radians. Both will be totally fine. All right, so if this reference angle is 45 degrees, and this is 180 or 4 pi over 4, what angle is that in that larger angle that I'm looking for? So the angle is going to be either 180 minus 45, which is 135, or 4 pi over 4 minus 1 pi over 4, which is 3 pi over 4. So, to now write my answer in terms of trig form, and that's the goal, is to take this guy and convert it to trig form, I'm going to get r, which is 2 radical 2, times the cosine of the angle, which is 135, or 3 pi over 4, plus I sine of 135. That's it. That's how I convert this to trig form. So, there's my answer. Nothing else to do. Now, if you want to be fancy, you can do 2 radical 2 cis 135. That's the short version of it, but here's the deal. You have to know what that actually means. So don't write cis 135 if you're not exactly sure that it's cosine plus I sine of that angle. So yes, that is an appropriate way to write it, but please make sure we know what we're saying. And if you actually replaced 135 with 3 pi over 4, great. Perfect. Okay. So if I were to evaluate this, I should get that. So both of these are showing the exact same thing. All right, flip to the next page. I'm going to let you look at the way I did that in the key, and I'm going to jump down to number 3, where I'm now converting from trig back to a plus bi form. To do that, it's simply evaluating. So I'm going to do 4 times the cosine of 5 pi over 6 plus I times the sine of 5 pi over 6. These are values that we know. How do we know them? Well, 5 pi over 6 is an angle in the second quadrant. It has a reference angle of pi over 6, which we know is 30 degrees. And ASTC tells us that the sine value is positive in that quadrant, and the cosine will be negative. So the sine of 30 degrees is a half. I'm going to place a half in there. The cosine of 30 degrees, we know is going to be negative, and it's radical 3 over 2. So now I'm just going to evaluate. I'm going to distribute the 4. I'm going to get negative 4 radical 3 over 2 plus 4 over 2i, and maybe simplify that a little bit. Negative 2 radical 3 plus 2i. So, a plus bi form, trig form. Trig form, a plus bi form. And you can continue to go back and forth. Again, you may not understand, why am I doing this? Why will I need this? Maybe later on, as I get through this, you will see, oh, okay, there's a little bit of a need. And next class, when we look at roots and roots, we'll definitely want to be in that form. All right, I'd like you to jump over to the next page. And on the next page, it talks about if I wanted to multiply 2 that are in trig form, or if I wanted to divide. So very easily, you'll see that if I multiplied 2 in trig form, I'm going to multiply the r's and add the angles. For division, I'm going to divide the r's and subtract the angles. So let's actually jump into one. All right, I got 2 trig forms. I want to multiply them. I'm going to take 8 and 6, and I'm going to multiply them together. Within my cosine, I'm going to add those angles. Cosine of 120 plus 150 is 270. plus I sine 270. So it's going to be 48 times the cosine of 270 plus I sine of 270. Now, we can go, that would be our answer in trig form, that's it. But if I wanted to then convert it to imaginary number, to a plus bi form, I would get, well, the cosine, I know at 270, this ordered pair is 0, negative 1. And I could make that 48 times, the cosine of 270 is 0. The sine of 270 is negative 1. That guy's gone, I'm going to get negative 48i. So that would be my answer for, if I wanted to convert that back to a plus bi form. Now, go back up and take a look at the other side. If I wanted to divide, what I would do is divide my z1 over z2, so 8 over 6. And now I'm going to subtract the angles. I'm going to start with my first. 120 minus 150 is negative 30. All right, I don't like negative 30, and I'm sure you don't either. So I'm going to make that 4/3 cosine of. If I go negative 30, it's the same as going 330 degrees. So that's it. That's my trig form. I've finished the problem, but maybe I might want to then convert it back to imaginary a plus bi form. So I go 4/3 times the cosine of 330 plus I times the sine of 330. That has a reference angle of 30, and so this guy, this sine is going to be negative, the cosine is going to be positive. I'm going to place those in. Let me pull this down a little bit. And then I'm going to go ahead and throw that through, distribute that through. I'm going to get 4 radical 3 over 6 minus 4 6i. And then I'll simplify that, 2 radical 3 over 3 minus 2/3 times I. So there's my 2. I can multiply, I can divide those two trig forms. On the next page, it gives you another problem, and you can take a look at my key to make sure you're understanding what we're doing. All right, so we've come to the last part, and hopefully you're staying with me here. What we wanted to do is to get here. And now here's the reason why we would convert from a plus bi form to our trig form. If you're given negative 1 plus radical 3i to the 12th power, that means you have to multiply that by itself 12 times. I'm going to tell you what, after about 4 times, I might make a mistake. 5, 6, 7, 8, and you know what, it might take you 4 hours to do it because it's a long, long process. So we don't want to do it. What we're going to do is make a shortcut, take a shortcut for this. To take a shortcut, we're going to use what's called de Moivre's theorem. So as we get through it, I'll show you what that is. The first step is to now get this into trig form. Way easier to do this problem. So I'm going to start by taking negative 1 plus radical 3i and converting it to trig form. That is going to help us do this problem in way less time. So, I will start, excuse me again, to go left 1 up radical 3, I'm going to get my r. 1 radical 3, r squared is equal to radical 3 squared plus 1 squared. R squared is 3 plus 1. So r is 2. So I got my r. My next step is to get my angle. Tangent of theta is equal to O over A, radical 3 over 1. My reference angle. We know what angle has a tangent of radical 3. Remember, that's going to be 60 degrees. So I am going to use 60. You can do pi over 3. It's your choice. I think it's easier to do this with degrees when we get to de Moivre's theorem. So, if my reference angle is 60, what's that large angle? This is a, whoops. This is 180 degrees. I'm going to chop off that reference angle to get myself an angle in the second quadrant. So hopefully you see the angle is 120 degrees. Perfect. All right. So now, how is this helpful? Let's write this in trig form. It's 2 times the cosine of 120 plus I sine 120. Now, this is in trig form, but I want to raise this all to the 12th power. By de Moivre's theorem, here's how easy it is. I'm going to take 2 and raise it to the 12th. I'm then going to take the angles and multiply them by 12. And now I'm going to evaluate that. Once I evaluate it and get it back to a plus bi form, I found my answer. Way less steps than multiplying that out 12 times. So 2 to the 12th is 4,096. When I multiply 12 by 20, I'm going to get the cosine of 1440 plus I sine 1440. Now, I don't want 1440. I want an angle that's coterminal with 1440. To find an angle that's coterminal with 1440, you have to subtract 360 until you are within where you want to be. Strangely, and I guess it's nice, when you subtract 360 and keep subtracting, you end up at 0. So that's nice. So the value, the trig ratios at 0 are 1, 0 over 1 up 0. So it's 4096 times the cosine of 0 plus I times the sine of 0. Well, the cosine of 0 is 1. The sine of 0 is 0. So I'm going to get, when I distribute this, 4,096. That's my answer. When you distribute that 12 times, you will get 4,096. Not sure that it would have taken us probably an entire block to do, or at least half a block. And this has taken us way less. So, the idea today, hopefully you got, was to take an a plus bi form and convert it to what we call trig form. By finding the r, which is using the Pythagorean theorem, the distance, and by finding the angle after you graph that imaginary number. And then writing it as r, parentheses, cosine theta plus I sine theta. We are going to continue to use this next class to help us get nth roots, but hopefully as you look through the rest of the notes with the key that I've handed out to you, you can kind of maneuver your way through the problems and hopefully find it pretty easy. So the rest of the block you can take to work on the homework assignment. It's posted at the front of the board, or hopefully the substitute will write it on the board for you. The books are in the sides and the back of the room. Go ahead and do that. Miss you guys. Hopefully you have a great morning. See you later.